Right. Well, I was just saying a little bit about Messier to start with. Not much. He was a French astronomer. He was actually a recorder, a kind of assistant to someone who was a noted French astronomer, Joseph Nicolas Delisle. I've never heard of him. Anyway, in 1758, Messier saw Halley's comet and immediately got hooked, and he spent the rest of his life searching for more. The king at that time called him the Comet Ferret. He actually discovered 13 new comets, and he obviously got so fed up looking at red herrings that he went through the sky to find out what fuzzy things weren't actually comets, which is a fair thing, to discover a fuzzy thing, and then a few days later come along, see whether it's moved. Okay, it's not moved, so it's not a comet. Anyway, he was limited to what he could do, which is actually relevant to a declination of about minus 35 degrees, which is the horizon he would have somewhere in France. It's like ours in Otley. Our southern horizon is about minus 36. In Otley, it's minus 23 because I've got this bloody hill behind me, which is called the Chevin. And I know it's that because the sun just beeps over the top at the winter solstice. Anyway, they were all fuzzy objects in those days, and eventually people started to sort them out. And the fuzzy objects actually come into different categories. First are straightforward star clusters, which is the Pleiades. There's an old picture of mine. It's showing a nice amount of blue there, but and then there are other clusters. Oh dear, what's gone wrong? Which are globular clusters. These are the ordinary clusters are just stars. These are ordinary stars, but they're not very ordinary. These are very, very old red giants, which have somehow got together in space, and you can have up to almost a million stars all clustered together. They look very spectacular, and I've often thought that living in the middle of one would look rather striking, but the average distance between them there's only a parsec or two in the most dense one, so it's not enormous. M13, which is this one, is one of the easiest and most spectacular ones to see from this country. This was done up at the New Inn some years ago. Um, and M13 is a pretty big one. It has 600,000 solar masses. Doesn't mean to say it's got 600,000 stars, because the red giants could well be bigger, but it's certainly got, oh, I don't know, many, many thousands of stars all clustered together around a nucleus. So, and the other sort of fuzzy objects which he had were gaseous fuzzy objects, which don't have any particular shape or form. It's like this one. This is uh, the Ring Nebula, and it's just a ring of gas, presumably expanding out from some event some time ago. And the last of the series are galaxies. This is a very old picture of mine of M31, which was done when my sky was a lot bit better than it is now. It might even have been done on film, but it's not terribly good. But it does have the advantage of having M32 next to it, which is pretty featureless. You can see some structure in M31. And no, that wasn't. No, this is another one of M31, bigger size, and M32 up there. And the final one, which is one of my earlier pictures, which I rather like, this is M82, which I always taken pictures of because it's an easy one, but this is when it had a supernova come up in it, which was discovered by students at the University College London who happened to be up at their observatory, and someone said there's something funny here, and they recognised that a little supernova had popped up in the middle of M82. So it's quite nice. Did anybody else see that at the time? No. Okay. Now then, what I've got to do now is change pictures here. No, that's one reason that Caldwell, in other words, Patrick Moore, wrote his list, that he wanted to include objects which went further south than Messier's, or Messier just showed all he could see. So Patrick wanted to include southern declinations, and he also added quite a few which were missed by Messier. And I gather from Rod's email this morning that there's an article in Current Astronomy now all about it with pictures and maps, which is very useful. I took my own maps off the web, and they're rather good ones. But anyway, so if you all rush out and buy Astronomy now, you'll get something for nothing. Well, not something for nothing, you paid for it. Okay, so what I'm going to do now is I'm sorry if it's a bit tedious, but it's not going to take too long. I'm just going to go through the pictures that I've taken on the Magic Evscope and take them one or another. I hope this is going to work. I've put them in Messier order in general, so that's M1, Crab Nebula. Crab Nebula is interesting. It does have quite a lot of structure.
We can't see anything different.
Yeah, I think you need to stop sharing your screen.
Okay,
and
right.
Start again.
Okay, right.
Yeah,
okay. Yes, I thought something like I'm going to stop share and start again. Got anything now?
Yeah.
Yeah, the Crab Nebula.
Yeah.
Okay.
Yes.
And it's interesting. When I taught the astronomy class in the university, we had a rather nice little exercise which had two black and white pictures of the Crab Nebula taken about 40 years apart. And you could measure various aspects of some of the structure in it against distant stars and work out how long ago it actually exploded. And the people used to get quite a good correspondence, which was, can't remember the exact date now, but it's some time ago. But it's a nice little exercise in seeing how something like that moves. It will be a bit tricky to do it over a short time. You need a lot of years anyway. Now let's see. So, okay, got a new picture?
Yeah.
Okay. So that's one of my M3s. This is now on the Evscope, which is actually not too different from what I did on a real telescope. That's M13, which is rather well placed. That come up quite nicely. And this is one of the nice objects. This is the the Hourglass Nebula, which is another gaseous nebula, and I quite like this one. I was very pleased to get that, called the Dumbbell Nebula. And then we come on to some ordinary star clusters, M29. And there's M32, which is a little tiddler next to M31, which doesn't show anything. I'm sure someone with a decent telescope could do rather better than that. And M35, another overall cluster, 37 cluster, 38 cluster, 39 cluster. And everybody's favourite image, of course, M42. For some reason or other, Unistellar sometimes leaves out the label from the bottom, but that's what it is. And that does show quite a lot of detail. That's more than I could ever get with a camera and another telescope. This was a sort of 3-minute exposure on the thing. And this is oh, it's an M50. Yeah, it's just a cluster. M52, another cluster. M53, which is rather nice little globular in a different part of the sky. And M56, another quite nice little globular, well surrounded. There's the Ring Nebula again, proper size. It looks much better in this smaller size.
You can also get a central star as well.
You can see the central star, yeah.
It's clearer on the previous one.
There's M59, which is a galaxy, no structure there. Sunflower Galaxy, M63. I don't know why it's called a sunflower, but you've got some structure there, not brilliant. One day when I get to somewhere where there's a decent sky, I'll rather do better. The Black Eye Galaxy, I like the Black Eye Galaxy because it's got this little black eye right in the middle of it. That's another one of it. And this is the Little Dumbbell Nebula, which is a rather tiny version of the Big Dumbbell Nebula. So that's one of Messier's, M76. This is Bode's Galaxy, which is always a blighter, very difficult. It's in the same part of the sky as M82, which is easy because it's thin and brilliant, but Bode is a bit of a pain. And there's an awful lot of noise there. I brought up too much noise there to get the structure, but it's not bad. And that's this M82 again with the no supernova. M86 and a little interloper up there. I don't know what that is, but it's some NGC, which I'll probably get a decent map. You could probably decide what it was. M90, another little spiral galaxy. M94, some hint of structure there, but not much. It's a bit overblown. And the pinwheel galaxy, which is sometimes that's even more difficult than Bode's galaxy, but at least it's got some structure here. But together with quite a lot of noise, because I brought it up too far above the black, but it more or less shows up. M103, complete with the satellite. M106, again, a little bit of structure, but not much. M108, sideways on, but not very bright. Oh, this was an NGC. I just picked this up quite by accident. It's rather nice. It is in fact one of Caldwell's, because I thought, oh, I'll try a Caldwell, and put that in, and there it was. And that's an easy one. It's rather good, that. I'm going to try and get more Caldwells now. This is the Owl Nebula, which is a rather difficult object up in Ursa Major. And it's again an expanding mass of gas, all green this time. And that little central star there might be the culprit. I don't know really, don't know enough about it. There's a 10-minute exposure it requires kind of. And that's M101, the Pinwheel Galaxy. And
are these all the same field of view, Robin?
They're all half a degree field of view, yes.
Right, yeah.
Ring Nebula again. Now this is Uranus, so this was as it says, 18.91 milliseconds, and you can just see the green colour of it, which is rather nice. Now this was longer exposures on Uranus, and you can start to see some little blobs circling around it here. And that's a blow up of one. And the nice thing about Uranus, of course, it's pointing its polar axis roughly at us. So these satellites you can see, one there, one there, one there, they're going round in one way or the other. So I was amazed when I saw that. I thought, well, it can't be real, but it was, because that's another nice picture of the and that's a nice one up in the Ursa Major, in the Whirlpool Galaxy. Shows the structure very nicely of the main galaxy, and there's just a little stretch of stuff. It's either pulling material out of there, or so they've got together and being a bit right. Well, that's yes, I think that's the end of that. It is the end of that, yes. So anyway, so that's my lot so far. I've put most of these on the web anyway, but I thought it might be interesting if you want 10 minutes just looking at a few things. And so I'll stop sharing now and come back to the real life.
Thank you. Thanks.
Yeah, very nice.
I'm just going to say, Robin, can you hear me?
Yes.
I was going to say, you mentioned Joseph Delisle, I think, at the beginning.
Yes.
I mentioned him in a talk about 2 or 3 years ago because
yes.
His brother wrote the Marseillaise, you know, the French national.
Oh, did he?
Yeah. Yeah. I don't think that's his one claim to fame. I think he was a famous person in his own right in astronomy, you know. But
yes, they call him a noted French astronomer.
Yeah,
yes.
yeah.
He coordinated a lot of the transit of Venus expeditions in 1761.
Did he?
Right, yes.
Yeah.
Yes.
Yeah.
Yes.
It was
Anyway,
interesting to see. It was interesting, Robin, to see them all because they were all the same field of view. You got a feel for the relative size of the different objects. That was good.
There is some advantage in that, but there are disadvantages because it's half a degree. I can't get anything sensible from the Pleiades or M31. All these things are much too big.
Right.
I suppose if I were to take a series of pictures of the Pleiades and then stitch them together, which I don't know how to do, it would be possible to do something, but we'll give that a miss. When I get a clear sky, I'll try it with a real telescope. Getting cold.
Mm.
I think Rod's trying to say something and he's muted.
Yeah.
Sorry?
Sorry. How many Messiers do you need now to get a full collection?
Oh, well, the number on the thing. I think
Got a
there
lot.
are. Can't find that. I think at the moment. Where has it gone?
Have we lost him?
Well, there's 109 listed, of which 2 don't actually exist. M40 is actually a double star. No one knows what M91 was. M102 is a repetition of M101, and M73 is only 4 stars. So there's 1, 2, 3, 4. So there are 105 genuine ones, and I think I've probably done about 40 or 50 so far. I haven't counted. No, not as many as that, about 35. So it's just a matter of waiting as the year goes round and seeing it. And I sent everybody copies of this map that I got of the Messier objects, which is rather nice. And you know, if you use that and you know your constellations, you can find them with a decent pair of binoculars. But if you wanted more detail, you'd have to go to something like Norton Star. Does anybody still use Norton these days?
I've got one, but I've not used it for a long time.
No, I got it many years ago when I got my first one. I still got the battered one. Anyway, if you ever get this edition, which is the 17th edition, and you look carefully at the frontispiece, you'll see that yours truly did a revision of it, because there were all sorts of mistakes in it, so they asked me to sort them out. So I actually got a free atlas for that. But it's good. It's got a lot of information in it. It even had, I think it still has, pictures of how to make your own telescope mount. One was made out of wood, which was quite fun, and the other was for someone with a decent lathe. You could actually, you know, make a full driven metal equatorial mount. Now, of course, we're totally spoiled. You just go to China and buy some amazing thing. You don't have to know anything about astronomy. You say, yes, I know what okay, go to M31, let's have a look at it. That's the lazy man's way of doing astronomy. And I think really everybody who uses telescopes should be prepared to use circles to find objects. But of course, it's easier just to use the automatic thing.
Okay, well,
Robbie,
thank you.
These Cardwell objects, how
Yes.
many of them is there? Do you know?
I don't. 69. 109 altogether. As far as we're concerned, in this part of the world, about 67, 68. All the rest are below the horizon for Leeds.
And they're on. Sorry, they're on some other catalogue, are they? I mean, it did. Patrick Moore just filched them from another catalogue and called them.
Well, yes,
objects.
they've all got NGC numbers and IC numbers. I mean, it's the same as the Messier objects. They've all got NGC numbers, which includes.
Yeah.
But if you haven't seen it, this is an example of the map of the Caldwell catalogue, and he does. It's a rather nice one. They're done in 4 seasons. This is a summer chart, and it covers everything, all right way down to the South Pole. So you won't see those. But it's a rather good map because it's nicely coloured, and they're shown with the constellations, which look very peculiar. I find the one with, because you know, maps are funny things, as everybody knows. And if you look at Ursa Major at the top there, it's a very, very funny shape indeed. It's bound to be, because the top, of course, it should be coming to a point. But I imagine, has anybody got the today's astronomy now and looked at it? Oh, you got it. Are they the same pictures, maps?
Nearly, not quite. I was just going to show that it's an enormous article. It's about 8 pages.
That's
and
useful.
if you can see that map, I think that's for now sort of spring.
I see.
And it's got all 4 seasons.
Maybe it's the same
with
set of
lots
maps.
photos, and then it finishes with a comprehensive list.
Yeah, can you show a map again? Because what we saw then was just a black thing with a few blobs on it.
I think that's a winter one. Don't know if you can see anything.
Well, no.
Can't see any detail.
Yeah.
You'll have to buy the magazine.
Yes, yes.
It's a good